Hi, welcome back to the Pre-Cal 40S videos. In this one, we're going to look at Chapter 7, and we're going to start on exponential functions, outcomes R9 and R10. This video that I'm going to do right here, we're going to graph and analyze exponential functions and logarithmic functions. So everything that applied from Chapter 1, you really need to make sure you have a super good foundation. If you're not familiar with the transformations from Chapter 1, then I would suggest going back, reviewing that, and then coming back to this. All right, so let's get started. We're going to look at the characteristics of exponential functions here. Now, an exponential function is where you have a base. Now, it doesn't matter what base you have, okay? And this is going to be all about the base. So any base works here. Could be any number here. You could use a B, a C. We're going to use a C just to represent a constant. Now here, our constant is going to be greater than 0, and X is the variable part here. All right. Now, in this first example over here on this side, we've got y equals 2 to the power of x. Now, this is typically what an exponential function looks like when your c value, or when your base, is greater than 1. It's going to be really tiny along where x is negative, and when x is positive, it's going to start exploding up super big. One thing when you're drawing these is that you're going to need to indicate that there's an asymptote at y equals 0. So what you do to do that is you extend the axis, because you see, if you draw it on here, it might not always be visible to the person who's marking. So they recommend that the proverbial they, which is the folks who are in charge of the exams and the marking, that you extend the asymptotes beyond the drawn axes with a dotted line and indicating that there's an asymptote there. So this would be all good. All right, so now I just made a quick table of values here for you so that you can see where my points came from. And then over here on this one, this is where C is in between 0 and 1. Now this example here is y equals 1/2 to the power of x. And I'm also going to do the same. I'm going to show that my asymptote is at y equals 0. Now what that means is in both cases, or in all of these exponential cases, is that my values are never going to cross the y equals 0 line. They're never going to cross the x-axis here and go beyond. There's just no number that I could input in here that's going to turn my y values to negative numbers. Because what's going to happen, it's your inputs are in your exponent, right? So it's not going to have any effect in terms of making the base a negative number. Try it. Knock your socks off. It's just not going to happen. Similarities, and let's compare the two graphs here. So we can see the two graphs in our image in front of us. We see that they both pass through the point 0, 1. Now that's right here and here. All right. So they're both this one here is an increasing function. So what that means is that as I move to the right, my y values get larger. And this one is a decreasing, which means when I move to the right, my y values get smaller. So they get smaller and they approach 0. They never get there, but they approach it. And the domain for both of them, which means any x value, can be inputted. So you could also write this as x is an element of the real number system, which means that every single x value goes in. This is in interval notation. So all the way from negative infinity up to positive infinity. Now the range for both of them is 0 to infinity. So that means that your y values are always greater than or equal to 0, if you want it in set notation. Our asymptote in both cases is y equals 0, and the point on the graph that they both have is 0, 1. So there's lots of applications for these exponential functions. For example, you've got physics, you've got half-lives and things like that you're talking about, and biology, bacterial growth, where you see an explosion of growth. You could also have the other way, where you have a decline. So it's called half-life. Wait, that's the same as this one here. Anyways, okay. So this next page here has a couple of examples that I'd like you to try. So make a table of values. So here, this is going to be your x, and while I clear my throat, this is going to be your 2 to the power of x. So why don't you give this a try? Press pause on the video, and then I'll come back with the answers. Did you hit pause yet? All right, so now that you've hit pause, hopefully, and you're back, welcome back, I'm going to show you what your answers would look like. All right, so here I've already taken the liberty to plot the table of values, where this is my 2 to the power of x here. And this is what my points, if I plot these points on here, will look like. So this is my -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. So you want to connect these with a smooth curve. All right, make sure you don't have any corners anywhere or anything like that, and put an arrowhead on this end, put an arrowhead on that end, and then you've got to extend the axes here with a y equals 0 asymptote. Beautiful. All right, next question. Sketch this function here. So this is y equals 3 to the power of x. So our base is changed. So notice that this value right here, it corresponds to that base right there. So 3. So when you put in a 1, you get a 3. And here, when you put in a -1, you get 1/3. There's my table of values to show you that. And we're going to simply just connect these with a smooth curve. So notice this one is steeper than the previous one. My base was bigger. And I'm going to extend my asymptote also and indicate that it's y equals 0 there. Okay, and now this last example here is when my base is a half. So when my base is between 0 and 1, what happens is my curve flips. It looks like it's going in the other direction. So it's going to be decreasing as x values get larger. And you know what? It's sometimes hard to draw the curve here. So what I'm going to do is I'm going to flip my page around, and then I can just do this nicer. So everyone is flipping their pages around when they're drawing these curves. It's quite wonderful. And then extend this so that it is a y equals 0 asymptote. And that just about covers the first part of it. So what I want you to do now is I want you to make sure that you read page 340, example 3, and I want you to complete the your turn in the textbook. And for your homework, complete the questions 1 to 5 and C1 on page 342. So have lots of fun and enjoy. See you soon.